notice that you have a table of values to the right of your screen here. Sorry, the right of your work there. That table of values is designed to help us understand what the base values of our graph are. So we are going to go and create a table of values for the x and the y for our graph. Now, Desmos doesn't understand that what y is. You actually have to tell it what y is going to turn into. And in this case, we actually have to say that y is equal to x squared. So what that's going to allow us to do is it's going to allow us to see all of the points, all of the key points for this parabola. The only key point that we can see right now is this point here, 0, 0, where our vertex is. And our axis of symmetry is our x value, also known as x equals 0. The optimal value is going to be y equals 0. Okay? Now, here's how you get Desmos to go and automatically generate and calculate all of the values that we need for x. So we're going to go from -3, and you'll notice -3 turns into x squared, right? And then x squared is calculated to be 9, which is just -3 times -3. Now, in order to get Desmos to calculate the rest of the points from -3 to +3, all we're going to do is we're going to take -3 and change -3 on the next line to be -2. And then Desmos understands that we have a pattern that we need to follow. We start from -3 and we're adding 1 to each one of our x's. And you'll see when you hit enter, you click on it, you hit enter for each one of the points afterwards, you get all of the values. And you'll notice that all of those points are now showing up on our graph for y is equal to x squared. So this is x, and then this value here in this second column represents the y value that is represented here. Now, let's go and take a look at our problem once again. Remember, we're going to start with y is equal to x squared plus k. We're going to type that in. And what I want you to understand is we're going to add this thing called a slider. And a slider is very powerful in the sense that we can visually see what happens when we change the values of k dynamically. Okay? So if I go and click this slider here, this goes and automatically shows me that when k is equal to 1, we see that our graph has actually moved up 1. And I can tell that from looking at my vertex of each parabola. So the first vertex is 0, 0. But the next vertex is translates up 1, or you could say shifts up 1, or moves up 1 unit. Does that make sense? Now, let's go and test our hypothesis. So imagine that we let k be, instead of 1, let's make it 5, right? So if it's 5, oh boy, if it's 5, if k is 5, you'll notice that the graph, its vertex compared to the original graph, is at 0, 5. Huh, that's interesting. So the vertex of the first graph is always 0, 0, but the second graph is always 0k. So the graph goes up k units, and the vertex is now 0k. All right, so the original vertex for our first graph, for the base graph, the vertex v is 0, 0. There we go. So the vertex for the base graph of y is equal to x squared is always 0, 0. But when we're talking about, when we're literally talking about the other graphs where we add some value to it, a positive value, the vertex shifts up, which means all of the points of the graph shift up. That's why it looks congruent to the original graph. Okay? So its vertex is now 0k. So now, what do you think would happen if we let k be negative? So in this case, we let k be negative, right? So now, if k is negative, there's our vertex. K is negative 5.5. Oh, wow. The vertex is just still 0k, but the k value is negative. So let's go back to our sheet and then write out some examples as to what you would see.